We're going to be working the homework for 7.3, computing the values of trigonometric functions. So the first one here just asks us to write down the exact value for all 6 trig functions for sine of 60 degrees. Well, for 60 degrees, the first one being sine. So the way we're going to do this is just remembering that first quadrant, those important angles that we had. And here's 60 degrees, and we know that the ordered pair, the point that corresponds to this, is 1/2 square root of 3 over 2. And so sine of 60 will just be the y coordinate. Cosine of 60 will be the x coordinate. Tangent of 60 will be sine over cosine, or you could say the y coordinate divided by the x coordinate, which, because you're dividing a fraction by a fraction, you can take the fraction on the bottom, flip it, do the reciprocal, and multiply it on top. When you do that, the 2's cancel. You just get square root of 3 over 1, which is square root of 3. And then now you do all the reciprocal functions. So cosecant of 60 degrees would just be the reciprocal of sine, so just flip over the sine. Secant of 60 should be flipping over 1/2, which is 2 over 1, which is 2. And cotangent of 60 will be taking the square root of 3 and flipping it, so making it 1 over root 3. So let's see how things go here. If I do a fraction, I do the square root of 3 over 2. Okay, and then cosine is going to be 1/2. Turn on my light here. Okay, and then we've got tangent, which is just square root of 3. And cosecant should be, let's see if it takes this, 2 over square root of 3. Okay, good, it took it. And then 2. And then let's see if it takes this 1 over, let's try 1 over square root of 3. Okay, next question. All right, so for the next one, it says if f of theta equals sine theta and g of theta equals cosine theta, find the exact value of the expression below if theta is 60 degrees. Do not use a calculator. So what they want to know first is, what do we get if theta is 60 degrees? And they want to know what's f of theta. Well, sorry, f of 60 degrees. Well, f is the sine function, so they just want to know what sine of 60 degrees is. And we just did that problem. That's going to be root 3 over 2. Let's go ahead and put that in. Square root of 3 divided by 2. All right. Okay, so now same thing. They want to know if f of theta is sine and g of theta is cosine. Find the exact value if theta is 60 degrees. So for here, we've got theta is 60. They want to know what g of theta over 2 is. So 60 degrees over 2, that's g of 30 degrees. So the g is the cosine function, so they just want to know what cosine of 30 degrees is. And we can go to our circle, we can go to that common angle, here's 30 degrees. That has the coordinates root 3 over 2, 1/2. And since we're talking about cosine, we're talking about the x coordinate, so the answer here is square root of 3 over 2. Square root of 3 divided by 2. And we're done. Okay, so now find the exact value of the expression if theta is 30. They want g of theta squared. Okay, so what that means for us is we want to know what g of 30 degrees, whatever that is, squared. Okay, now g is the cosine function, says it there, so we want to know what cosine of 30 degrees squared is. Now cosine of 30, we just did that. Here's 30 degrees. Cosine's just the x coordinate, so It's root 3 over 2. So this is going to be root 3 over 2. But then we need to square that. And when you square a fraction, you can square the top and bottom separately. And when you square the square root of 3, all you get is 3. And when you square 2, you get 4. So we should just get 3/4 here. 3 divided by 4. Oops, not 5, 4. There we go. Okay, so now compare that to this one. They want to know what g of theta over 2 is, but here theta is 60 degrees. So they want g of 60 degrees divided by 2. Now be real careful here. We're not saying what is g of 60 degrees over 2, because this 2 is separated by this bar. The bar is not inside that parentheses. So we need to figure out what cosine of 60 is first, then divide that by 2. So cosine of 60, I go to my angles here, this one, that has an x-coordinate of 1/2. So that's what we're interested in because we're talking about cosine. So I'm going to do, this will be equal to 1/2 divided by 2. I'm going to write 2 on the bottom as a fraction. Then I'm going to flip it and, oops, did that wrong. Flip it up. Okay, and then multiply straight across, and I just get 1 over 4. So 1/4. Oops. Did I not hit enter? Okay. All right, so here they want the exact value of 4 cosine of 30 degrees minus 5 sine of 30 degrees. All right, so let's figure out what these values are. For 30 degrees, we're here. That's root 3 over 2, 1/2. So this can be 4. Now cosine, that's times. Cosine is root 3 over 2, cosine of 30, and then minus 5 times sine of 30 is 1/2. All right, so what happens here? This is really like 4 root 3 over 2, because you're treating the 4 like a 4 over 1. Same with this 5 over 1, multiplying straight across. Okay, since they both have the same denominator, we can put it together and just be 4 root 3 minus 5, all of that over 2. Let's try that. Okay, so I'm going to type in as a fraction up top, I'm going to go 4 square root 3 minus 5, and then on the bottom 2. Let's see if it takes it. Good. Now, the next one is very similar. We're going to be doing, let's see, 2 tangent of 45 degrees plus 10 cosine of 60 degrees. All right, so we're going to need to know what's happening. First, let's look at the 45. 45 degrees. This is root 2 over 2, root 2 over 2. And tangent of 45 will be the y divided by this x. And those are the same values. So when you take something and divide it by itself, you get 1. So we get 2 times 1 plus 10 times, now cosine of 60, 60 degrees is here. Cosine is the x-coordinate, which is 1/2. So we're going to take that 1/2, we're going to multiply here. And so you get 2 plus 1/2 of 10 is 5. So we should just get 7. All right, similar problem, except we have some radians now. So first thing is we want secant of pi over 3, and then plus 4 cosecant of pi over 6. All right, let's talk about this first one, secant of pi over 3. So pi over 3 is here, that's pi over 3. The x-coordinate here is 1/2, y-coordinate is root 3 over 2. Now secant, remember, secant is the same as 1 over cosine of pi over 3. So it's the reciprocal. So there's 2 ways to look at this. I could just replace this cosine of pi over 3 with 1/2, which is what it is. Okay. Or I could have just told myself here at this point, I could have said, hey, I just need the reciprocal of cosine. Since I know that cosine is 1/2, I just flip it over, it becomes 2, which is what you get when you do this step. That's just going to become 2. Either way, I like to do it here because then I don't have to write this down. So let's see if we can use that same principle here on this next one. So we're going to have 2 plus 4 times now cosecant of pi over 6. So I need to go to pi over 6 over here in blue. And that's root 3 over 2, 1/2. Now, cosecant is the reciprocal of sine. So I need, sine is the y-coordinate. So I take 1/2 and I flip it over, it becomes a 2. And so this just becomes 2 plus 8, which is 10. And that should be it. All right. Now this next one, you may be a little tempted because we have a Pythagorean identity, a very important one that says anytime you have sine squared theta plus cosine squared theta, you get 1. But for that to work, these two thetas must be the exact same thing. And in this problem, we have sine squared 60 degrees plus cosine squared 45 degrees. And since these two are not the same, we can't use the formula. So we're just going to have to figure out what these are. So first one, all right, so just to be clear, what we have here is we are going to take sine of 60 degrees. So what this notation means is or what that 2 here means is that we're going to take sine of 60 degrees first and then square it. And then same thing on the other one. We're going to do cosine of 45 degrees first, and then we're going to square that answer. All right, so sine of 60. I'm not going to write it down. I'm just going to trust now that you could draw your little quadrant and go to 60 degrees and find the y-coordinate. This should be root 3 over 2, that's sine of 60 degrees, but then you need to square it, plus cosine of 45, so that's the x-coordinate of 45 degrees, which is root 2 over 2, and square that. And now what we do is we square each one. So we square the top and bottom here, we'll get 3 over 4 here, plus on square top and bottom here, we get 2 over 4. Since they have the same denominator, we just add the numerators up, so you get 5/4. 5 divided by 4. I'm doing good. All right, next one. Use a calculator to find the exact approximate value, round to 2 decimal places. I'll do just this one. I'm going to make sure I am in degree mode because I'm given 11 as degrees. I'm going to type in tangent of 11. And when I do that on my calculator, I get 0.19438, blah, blah, blah. It keeps going. And I want to round 2 decimal places. So I go to the second decimal place. I look to the right. I have a 4, which means I do not round that 9 up. So it's just going to be 0.19. Had that 4 been a 5, I would have rounded this up, and that would have become a 0 and carry the 1. It would have become 0.20, but that's not what I had. So 0.19. All right. All right, so this one's a good one because depending on your calculator, this may be different for everyone. So we need to do sine of pi over 5. So I want to be in radian mode. And the reason I'm in radian mode is because the pi over 5 is not given in degrees. There's no degree symbol there. So I need to switch my calculator to radian mode, which I'm doing right now. Okay, and now I'm going to do sine. And then my calculator actually has a pi key. All right, but if you don't have a pi key, you could use 3.1415. I think we had said in class, if I'm not mistaken, I think we had said that we could go out to like 9.2, that would be sufficient for most of the problems we're going to do in this class. So I'm going to go ahead and do that. I'm going to do sine on my calculator and do sine. Then I'm going to go 3.141592. I'm going to divide that by 5. And let me see, when I divide that by 5, I have to do that before I hit the sine button. 8,318, something like that. And then I take sine of that. And I get somewhere approximately 0.58778, something like that. I want to round 2 decimal places, so I look at that 8, I go to the right, there's a 7. which means I want to round that up to the 8 to a 9. So I'm going to go with 0.59. There we go. Okay, so secant of 3 pi over 8, this is a good one to show you how to do this. So if we're going to do secant, most calculators do not have a secant key. So the way we do this is we realize that secant is 1 over cosine. Okay, now I'm going to approximate I'm going to go ahead and figure out what all this in here is. So on my calculator, I'm going to go 3 times pi, and you can either use the pi key or you can use that approximation we talked about a second ago. So this is going to come out to be 1 over cosine of, let's see. Oh, I forgot to divide by 8. Divide by 8. Oh, wait, I did divide by 8. Sorry. Hold on, let me try that again. 3 pi cosine of 1.178097. That's what I get there. So now I'm going to do cosine of that on my calculator. So cosine of that number. So I get 1 over 0.989176. And now I'm going to do that on my calculator. So 1 divided by that answer. And I get about 1.0109. And it's rounding 2 decimal places. So I'm looking at the 1 here. To the right is a 0, so I'm just going to leave it. So 1.01. And by the way, I was in radian mode again. I didn't mention. Uh-oh. Okay, so what did I do here? Maybe I did too much rounding. Sure, I type that in. 3 times 3 pi over 8. Oh, crap. Sorry, I looked at, no. What did I do? Oh. Oh yeah, I messed up. Okay, so sorry. When I did this was all correct. I hit the wrong key on my calculator. This was right, this was right. This number's wrong. Hold on, I need to redo that one. I picked the wrong one. Okay, sorry about that. Cosine of 1.178097. There we go. Okay, so this should be 0.415176. And then when I divide that, I get about 2.4086. And then I'm going to round that one, so it's going to go up to a 2.41. Okay, try that. What is going on? Let me see. Maybe I rounded it too much earlier. I'm going to try it again. I want to get it wrong. 2.61. What the heck? All right. Well, this happens. I need to run through all this again. Apologize. I want to get this one right. So let me clear all my work. Okay. So I'm doing secant of 3 pi over 8. Okay, so let me just do 3 times pi, divide that by 8 first on my calculator. So I get secant of 1.178097245. Okay, and then secant of that really means 1 over cosine of that. Okay, so now I'm going to do cosine of that. Wow, okay, so why did I get something different last time? I messed something up, not sure what. Something like that, and then now 1 divided by that. Yeah, it's about 2.6131. And I go to here, look to the right, don't round it, so 2.61. I don't know what I did. I messed up. Oh well. Next question, I move on. Okay, sine of 1 degree. just use a calculator. Make sure you're in degree mode. Okay, I'm not going to do that one. Move on to the next one. Tangent of 0.4, make sure you're in radian mode. Do that one. Should be able to get that. Okay, so here's something different. All right, so we want to find the value of f minus g of 60 degrees. Okay, so what you need to know from college algebra is when you see this notation, it means you take f, plug in the 60 degrees, and subtract from it the g with the 60 degrees. That's just subtraction of two functions. Now for us, the f is the sine function, so this is going to be sine of 60 degrees, minus the g function, which is cosine, so cosine of 60 degrees. And then if you go to your circle, you'll find that 60 degrees, the y coordinate is √3/2, and then the x coordinate at 60 degrees is 1/2. And since they have the same denominator, you can subtract, and we just leave it like that. So we should have a fraction, and we want the top to be square root of 3 minus 1. Divide that by 2. All right, this problem is very similar, except a different notation here. We have f dot g of pi over 4. And so again, from college algebra, this means you take the f function, plug in pi over 4, and then multiply the g function at pi over 4. And so the f function is sine, so sine of pi over 4 times cosine of pi over 4. And then you go to your circle, or you go to your angles, the common angle pi over 4, that's like 45 degrees. And that's √3/2, √2/2. So sine of that is √2/2, and then multiply it times the same thing. And so going straight across, you get 2/4, which is 1/2. All right. Okay, so now we do composition. So here we have that we want to find f with the little o in front of it, f of h of pi over 3. So what this means is we're going to take f. Inside of f, we're plugging in the h function, and inside the h function, we're plugging in pi over 3. So what is the h function? It's x over 2. So that means all we're going to do is take pi over 3 and divide by 2. Stop it. Sorry, my dog is at the door. Leave me alone. He won't listen. Okay, so when you do pi over 3 divided by 2, it's the same as dividing by 2/1. Then you flip it, and it becomes pi over 6. So this really is pi over 6. F of pi over 6. Now, f is the cosine function, so we really want to know what cosine of pi over 6 is. And let's see, cosine at pi over 6 is 30 degrees, so cosine is the x coordinate, should be just √3/2. Square root of 3 divided by 2. All right. I'm going to have to pause the video. You're not going to know that, but give me just a second. All right, so for this next one, it tells us we have a right triangle that has a hypotenuse of length 2 inches. So here's a right triangle. We have a hypotenuse that has a length of 2 inches. And one of the angles is 43. So we know it can't be the right angle. It's got to be one of these. So I'm just going to label this one 43 degrees. And it wants to find the length of each leg. So I'm going to call this side A and this side B. Now, what we know is that our trig functions are defined by ratios of the sides of these triangles. For example, sine of some angle theta will be the opposite over the hypotenuse. Now for us, if we look at this triangle, sine of the angle that we know, 43 degrees, should be the opposite side, which is B, we don't know it, over 2. But that's okay because we can multiply both sides by 2 and we'll know what B is, right? So I'm just going to use my calculator to do 2 times sine of 43 degrees, and I'm going to make sure that I'm in degree mode. I almost messed up, but I switched to degree mode. And I should get a decimal, about 1 point. They're going to want us to round to the nearest tenth. So 1.36. So this is going to round to be 1.4. Okay, that's one of them. Now I have to find the other one. So the other one I can use, so A here that we're looking for is the adjacent side. So why don't we use adjacent and hypotenuse again? So we know that cosine of 43 degrees will be the adjacent side over the hypotenuse, and I multiply both sides by 2 again, and we get A. So now my calculator, 2 times cosine of 43 degrees. And so I get about 1.46 is A, and I'm going to round that to 1.5. They want to the nearest tenth. So that's A. So now it says the length of the shorter one. So the shorter one is 1.4, and the longer one is 1.5. All right. All right. Suppose you're headed toward a plateau 50 meters high. If the angle of elevation to the top of the plateau is 60 degrees, how far are you from the base? So I guess what they're saying is here's the ground, and you have this plateau, which is just this like a cliff, okay? And we know that this cliff is 58 meters high, all right? And then we're standing here, and our angle of elevation, which is basically the angle going from us up to the edge of the plateau, they're telling us that that's 60 degrees. And the question is, how far away are we? Okay, so that's this. Now, remember, we have a right triangle here. Here's our right triangle, right? And we know the opposite side, right? We know the opposite side of our angle, and we want to know the adjacent side. And the trig function that connects those two together is tangent. Tangent of any angle should be the opposite over the adjacent, SOHCAHTOA, right? And so I can say that tangent of 60 degrees is equal to the opposite 58 over the adjacent, I'll call A. And so now what we need to do is figure out what A is. So we have to be a little careful here. I'm going to multiply both sides by A. The A's cancel here. So now I have A tangent of 60 equals 58. Now I'm going to divide by tangent of 60 degrees. So I'll do this on my calculator because they want us to round to the nearest hundredth. So I'm going to, on my calculator, I'm going to do 58 divided by, and make sure I'm in degree mode, which I am. I'm going to do tangent of 60 on my calculator, tangent of 60. Is about 1.732050808. Do 58 divided by that, and you should get that A is about 33.4863, and they want us to round to the nearest hundredth. So this is tenths, this is hundredths. So we look at that number, it's a 6, we're going to round that 8 up to a 9. So we're going to get 33.49 meters. 33.49. We're making headway here. Did I continue recording? Okay, good. All right, so a blimp suspended in the air at a height of 600 feet lies directly over a line from a sports stadium to a planetarium. If the angle of depression from the blimp to the stadium is 36 degrees, and the angle from the blimp to the planetarium is 25 degrees, find the distance between two. So they have a picture over here. Was there a picture on that last one? Okay, yeah, I didn't even notice it. There's a picture over here. So we have the ground. We have a blimp up here. I'm going to just say it's a point. We have the stadium here, which I'm going to say is a point. We have the planetarium here. This is the blimp. And what they're saying is that from the blimp looking down to the planetarium, that the angle that we form here, that's angle of depression is 25 degrees. The angle of depression here is 36 degrees. And they're telling us that the blimp is 600 feet off the ground, so 600 feet high. And it's going to want to know, find the distance between the sports stadium and the planetarium. So they want to know this total distance right here. Okay, so hopefully what you can see here are two right triangles. Here's one, okay? And then the other one is here. And we know something about these angles. So let's talk about the pinkish red one first. We know that this angle from here to here, that's 90 degrees, but this angle here is 36. So if we just take 90 and we subtract 36 from it, we know that this angle right here is 54 degrees, right? And then if we know that that's 54, we know this one also, right? This one would then have to be 36. And let's do the same thing for the other one. If this is 25 degrees, then this must be 65 degrees because those add up to be 90. And that means that this must be 25 degrees. All right. So now, at this point, here's what we could imagine doing here. We could try and figure out, let me see, we could try and figure out this distance first. And then we'll come back after we do that one, we could try and figure out, let's say this distance here. And once we have those, we'll add them up. Okay, so let's do this first triangle here. We have this. We know this is 600 feet. And then we know this is 36. And we also know this one's 54. We can use either angle, but we have to be careful. We're looking for this side. I'm just going to call this side, well, let's just call it A. All right. So if we want to use this A, if we want to find this A and we want to use the 600, then if we look at the 36 degrees as the angle we're going to work with, then this side would be opposite and this would be the adjacent. Now, if we decided to use the 54 degrees instead, then this side would be the opposite and this side would be the adjacent. So I'm going to stick with the 36 degrees, all right? So what I know is that, let's see, with the 36 degrees, I'm working with the opposite over the adjacent. That's tangent. So tangent of 36 degrees is the opposite 600 over the adjacent, which is A. We don't know. I'll multiply both sides by A. And then I'll divide both sides by tangent of 36. I'm gonna do this on my calculator. I'm gonna do it all in one step. Okay, so 600 divided by tangent. Make sure I'm in degree mode, which I still am. And I get approximately 825.8291. We're gonna round 2 decimal places, so that should be good enough. All right, and now I've got to do the same thing for the other one, the other triangle over here. So I've got this triangle here. We want to know this, I'll call it A. This is 600. And let me use the 65 up here, just show you how this would work. So if I use the 65, then this is the opposite side to the 65, and this is the adjacent side. So that's again tangent. I know tangent of 65 degrees is the opposite, which is A over 600. And I like this way because all I have to do is multiply both sides by 600. And I'll get A right away. I don't have to do what I did on the previous one. And so in my calculator, 600 times tangent of 65 degrees is about 1286.70415 is A. Okay, so now we're just going to take these two answers and add them together. So add to that the answer we got a second ago. And so I get an answer of about 2112.5333 We're going to round 2 decimal places, so we're going to round to that one. So that's a 3. We just leave it alone. So it should be ready. 212.53 feet. Oh, goodness. Oh, I typed it in. 2112.53. Oh, no, after all that work. Okay. All right, so let's see, 21. To measure a stone face carved on the side of a mountain, 2 sightings 600 feet from the base of the mountain are taken. All right, so if the angle of elevation to the bottom of the face is 35 degrees and to the top is 39, what is the height of the stone face? All right, so this one's a little weird. So we have us on the ground, right? And we're measuring a stone wall, and there's like a carving of a face here. So here's my face carved in. It's just going to be a little smiley face. Okay, there we go. So what we measure is, well, oh, they're telling us we're 600 feet from the base of the mountain. So we're 600 feet from here. And we measure that the angle from here to here, that's the top one is 39 degrees. That's from here to here. But then when we do the angle going from here to here, the bottom, we get that angle is 35 degrees. And so what they would like to know is what is the height of the stone face? So they want to know, what is this distance right here? Okay, so again, I hope you see 2 right triangles. We have a blue right triangle. Oh, that's not blue. Let me undo that. Sorry, where's my thing? So we have a right triangle here. Okay, and that right triangle looks like this. 639 degrees. And then this side right here, the whole way, I don't know what it is, I'll call it B. Okay, and then we have a smaller triangle, this is the red one. Okay, it's a right triangle. These are both right triangles. 600 here, 35 degrees, and then this side over here. I'm not going to call it B because I already called that other one B. I'll call it B. Who cares? Red B instead of blue B. And so if we want to know this here, right, it should be just the difference of those. So it should be whatever this one is, take away this one. So it should be the blue B, take away the red B. That should be this. So let's do this. Let's get the blue B. I should have gone with different letters. It's okay. So let's do the blue B. So for the blue B, I have opposite over adjacent because I know that my angle's right here. So I know tangent of 39 equals B over 600. So I multiply both sides by 600, kills it off. And now I just need to go on my calculator, 600 tangent of 39. And that's going to be about 485. We're going to need to round 2 decimal places. So 8704 should be good for now. And now in the red one, the red B, we're going to just set up the same thing, tangent, because we have opposite is the B, the red B, and then the adjacent is 600. So multiply again by 600 on both sides, kills off the 600. And I do that on my calculator, 600 tangent of 35. And I get 420.1245 is B. Okay, so now let's do this. Let's take this one, subtract that one. I'll do that on my calculator. I get 65. So this is going to be 65.7458. I'm going to round to the nearest 2 decimal places, some around there. That tells me to round it up, so 65.75, and this was feet. So 65.75. All right, next one. A radio transmission tower is 200 feet high. I'm just going to start drawing pictures. Radio transmission tower is 200 feet high. Okay, here's my radio transmission tower, 200 feet. All right, how long should a guide wire be if it is to be attached to the tower 14 feet from the top and make an angle to the bottom of 45 degrees? So we want to attach a wire that's going to be right here, where this is 14 feet from the top. And we want it to come down here at a 45-degree angle. And we want to know how long the wire needs to be. So let's just call this H for hypotenuse. We want to know what that is. Well, we have a right triangle here, but the side of the right triangle that we're looking at is not 200. You have to realize, since we've moved down 14 feet, that this should be 200 take away 14, which makes it 186 feet is the distance from here down. So our triangle actually looks like this, and then 45. And we want to know the hypotenuse. So we have this angle, we have the side opposite of it, and we have the hypotenuse, or we're looking for the hypotenuse. So that's going to mean that we need to use sine, because sine is opposite over hypotenuse. So we get 186 over h. I multiply both sides by h to get it out of the denominator. Okay, h here, h there, and then now I divide by sine of 45. So h is equal to 186 divided by sine of 45 degrees. Make sure I'm in degree mode on my calculator. 186 divided by sine of 45 degrees. I get approximately 263.0437. I want to round to the nearest hundredth, tenths, hundredths. So there's a 3 there. I'm going to leave that alone. So I should go 263.04. Oh, that's incorrect. Okay, so I messed something up here. God works. So just make sure I get 14 feet from the top. 186. Okay, we want it to be 45 with the ground. So we want that 45 in degree mode. Do not round to the final answer. Did I type it in right? Yeah. Round to the nearest hundredth. 10 hundred. Okay, something ain't right here. So 186. Let's try something this way. 186. Just hold on a second. Oh, shoot. I know what the problem is. Sorry, everyone. I misread the problem. It was 220 feet, not 200 feet. Dang it. Okay, well, how's that going to change things? 220. When we take 14 feet away from that, we're left with 206, right? And then from there, the only thing that changes, this should be 206. All right, my fault. 206. I swear I saw 200. All right. So I'm going to now do 206 divided by sine of 45 degrees. All right, so this should give us 291.3279. And now when we round to the nearest hundredth, we have a 7 here, so that is going to go up 291.33. Okay, so all my work was correct if that would have been 200, but it wasn't. It's 220. So, you know, it happens. 291.33. There we go. All right, last one. A highway whose primary directions are north-south is being constructed along the coast. Near a city, a bay obstructs the straight path of the road. Since the cost of a bridge is prohibitive, meaning too expensive, engineers decide to go around. The illustration shows the path they decide on and the measurements taken. What is the length of the highway needed to go around? Okay, so I guess what they're looking for here is the length of the highway to go around. They're talking about this, this, and this. Okay, they want to know how long that is. So let me start drawing here. we have this dotted line, which would have been the straight line. Then we have this section that's going to go up, then this section that's going to go over, and a section that's going to go down like that. All right. Now they tell us that the angle, oh, what else they tell us? They tell us that this is 1 mile. They tell us that's 1 mile. And they tell us distance from here to here is 9 miles. 1 mile, 9 miles. Usually it's mi, but okay. So let's start looking at what we've got here. We have a right triangle for sure. We have a right triangle here, right? And we know that this side's 1. We also know that this angle is 140, and since all the way across should be 180, that means that this angle should be 40. So we've got this triangle right here. 40, right, 1, and then we can find this side. I'll call it H1. I'll call it hypotenuse 1. Okay, that's this side. Okay, and then we have this piece of road here in red, which I'm just going to call X. I don't know what that's going to be. And then we have this hypotenuse, which I'm going to call H2. That comes off of this triangle, which is, let's see, we know this is 1. And because this angle here is 130, that means that this angle is 50. And so we have this 50, right angle, and 1, and then hypotenuse 2. Okay. Now, we should be able to find hypotenuse 1, hypotenuse 2 from these two triangles. We still don't know how to get X yet, but we'll get back to that in a minute. Let's find hypotenuse 1. I have 40 degrees. I have the opposite and hypotenuse is what I'm looking for, so I'm going to use sine. Sine of 40 degrees should be opposite over hypotenuse, H1. I'm going to multiply both sides by H1 and then divide both sides by sine of 40. So H1 should be, on my calculator, 1 divided by sine of 40 degrees. So this should give me about 1.55572. Okay, so that's H1. Let's go get H2 over here. So again, 50 degrees, I have opposite, and I'm looking for hypotenuse, so I'm going to do sine of 50 degrees. Should be opposite 1 over hypotenuse, H2. Multiply both sides by H2 and divide both sides by sine of 50. We've done that a few times now, so I'm hoping you understand what I'm doing there. Okay, on my calculator, I get H2 is approximately 1.3054. Okay, so we know now this, and we know this, and we need to still figure this out. Now we know that the whole distance from here to here is 9 miles. So because we actually have right triangles here, I should be able to find that distance. That we should be able to get off of this triangle. And I should be able to find this distance here off of this triangle, which means that I would then be able to find this distance in between, because if the total is 9, that would be this plus this would be 9. If I know this and I know this, I just take those, subtract from 9, I get this. So let me do this. I'm going to now go back to my triangle. Let's do the blue triangle here. And I'm going to call this side right here, I'm going to call this adjacent 1 or A1. Over here on this other triangle, I'll call this A2. Okay, but let's start with A1. A1 on our picture is here. A2 on our picture is here. So how do we find A1? I have the angle. This is the opposite. Now that's the adjacent, so that's tangent. So I can write tangent of 40 must be equal to opposite over adjacent. So that over A1. I multiply both sides by A1 and divide both sides by tangent of 40. And so I get 1 divided by tangent of 40 on my calculator. I get about 1.19175, something like that. That's A1. Now to get A2, I'm going to do the same thing. I have 1 here, I have 50 degrees, so I have opposite. I'm looking for the adjacent. So I'm going to use tangent. So tangent of 50 degrees should be the opposite over the adjacent, which is what I want to know, A1, or sorry, A2. Multiply both sides by A2, divide both sides by tangent of 50. And so I do that on my calculator. I get A2 is 0.839099. All right, so I'm ready to put this together. I know A1 is this. I know A2 is that. So if the total was 9, then this piece in the middle, which I'm calling X, should be equal to 9, take away A1, take away A2. All right, so I'm going to have to do that on my calculator. 9 minus. Okay, so here's what I get for X. X is approximately equal to 6.9691. All right, let's go with that. So we're ready for our final answer. What we need to do is we need to take H1, which is this part right here, add the X, which we just got to be this, and then add the H2, which should be, where's H2? H2 is here. So I'm going to be adding on my calculator these numbers, this one, this one, this one. So plus 1.3051 plus 1.55572. So I get a final answer. My final answer is 9. Well, not final answer, my calculator answer. And I want to round this 2 decimal places. So 83, and then there's a 0 there. So I don't worry about it. So it's just going to be 9.83 miles. I hope. Yay. Okay. That was a good problem. All right. That's it for this. Hope that helps.